2011, an experiment shook the world's greatest scientists.
When the electrons are deflected, you generate synchrotron radiation.
Light, the fastest phenomenon in our universe.
Inside a lab in Switzerland, some neutrino particles were observed traveling faster than the speed of light. For science, this was catastrophic, because it meant time travel could actually be possible. It meant you could go into the future, or return to the past, maybe even change your own history.
It doesn't matter how small it is, faster than light. The fact it is close to light, or just over the speed of light, changes our fundamental understanding.
Some people believe it wasn't just an experiment, it was a signal that the structure of time had started to collapse.
Some supercharged particles may have gone even faster than the speed of light.
And then came another twist. A man appeared on an online forum claiming, "I'm from the year 2036. His name was John Titor. He revealed blueprints of time machines, future wars, and unknown technologies. People laughed at first, but then some of his predictions started coming true. So the question arose, was it just a coincidence, or was he a real time traveler? But here comes the darkest question of all. If time travel is truly possible, what would be its consequences? Just imagine, if you traveled back in time and killed your own grandfather, would you still exist? And if you do, how? This question has haunted scientists for decades, because if time can be altered, the laws of the universe might fall apart. And if we ever move faster than light, will our atoms disintegrate? Or worse, will we fall into an alternate universe? Imagine this, you're running at full speed on a road, but suddenly you feel like some invisible force is holding you back, stopping you from going any faster. That's exactly what happens in our universe. The universe has a speed limit, and it's not just a rule, it's a cosmic law. 299,792,458 meters per second. That's the speed of light, and nothing can move faster than this. No matter how powerful your engines are, no matter how much energy you use, you just can't go beyond that speed. But why? Why can't we break this mysterious barrier? Why does the universe scream, no, when we try to move faster? The answer lies in one of the strangest theories ever explained. According to Einstein, as you move faster, time starts slowing down for you, distances begin to shrink, and your mass starts increasing. At low speeds, these effects are barely noticeable, but the moment you get close to the speed of light, everything becomes strange. Imagine a spaceship traveling at 99% of light speed. For the people inside, time would move so slowly that what feels like just a few months for them could be 100 years on Earth. This phenomenon is called time dilation. The closer you get to light speed, the slower time moves for you. But what happens if we actually go beyond the speed of light? Will time come to a stop? Will time start running backwards? Or will we break the very fabric of reality? And this is where things start to get even weirder. In 1971, something mind-blowing happened. Scientists conducted an experiment with two synchronized atomic clocks. One was kept on Earth. The other was taken aboard a high-speed jet plane. But when the clocks were compared after the flight, the clock on the moving jet was slower. Time had actually moved slower for the one in motion. And this isn't just theory. Astronauts living on the International Space Station, they actually age 0.01 seconds slower every year, just because they're moving faster than people on Earth. Now imagine, if we could move even faster, close to 99.999% the speed of light. For you, time would become so slow that by the time you return home, centuries may have passed on Earth. But wait, so far we've only talked about approaching the speed of light. But what if we actually break that barrier? That's when we face another strange and terrifying challenge. Mass increase. Let's say you try to push a spaceship near the speed of light. Something strange starts to happen. The faster you go, the more mass your ship gains. And as you get closer to light speed, your tiny spaceship becomes so heavy, its mass could be equal to an entire planet. And if you ever reach the speed of light, your mass would become infinite. Yes, something so heavy it has no limit. But here's the real problem. To move something with infinite mass, you'd need infinite energy. And even if you gathered all the energy in the universe, you still couldn't go faster than light. But what if there's a loophole? What if we don't chase speed? What if we bend space instead? What if we warp time itself? That's what we'll explore in the final part. Breaking the speed of light isn't just about going fast. It's about shattering reality itself. If somehow we manage to cross this ultimate limit of light, we won't just be moving faster. We'll be tampering with time, space, and causality. But what would be the consequences? That's the biggest question of all. Light speed is a universal barrier, and breaking that barrier means breaking the laws of time itself. When we move close to the speed of light, time starts to slow down. That's what we call time dilation. But what if we go even faster than light? Will time start moving backward? Or maybe something even stranger will happen. Could we travel back into the past? Could we fix our mistakes? Or would we enter an alternate reality altogether? Because when we talk about breaking the speed of light, it's not just about speed anymore. We're ripping through the structure of time itself. And if that happens, things won't just be bizarre, they could be terrifying. Is time just an illusion? Can we take control of time? Can we unlock an entirely new dimension? If the answer is yes, then we wouldn't just travel through time. We'd be playing football with time itself. But hold on, there's a bigger twist. If we break the speed of light, we'll face a whole new kind of nightmare. Paradoxes. Time travel isn't just thrilling, it's science's greatest shockwave. What if we go back in time and change our past? Would we still even exist? Or would we create a paradox so powerful that it could destroy reality itself? You're sitting inside a faster-than-light spaceship. You set the destination to 50 years into the past. And when you arrive, you realize you haven't even been born yet. Sounds exciting, right? But this is where the horror begins. Standing in front of you is another version of you. A version that was never supposed to exist yet. And what if you change your past? What if you kill your grandfather? Then you would vanish too. This is the grandfather paradox. And it's only the beginning. If you go back in time and kill your grandfather before your father was ever born, then how were you ever born? And if you were never born, who killed the grandfather? This paradox breaks all logic. But if we ever manage to break the speed of light, this paradox might not remain just a theory. It could become a real-world nightmare. But is there a way out? Maybe, instead of changing history, you simply enter a whole new reality. Imagine this. You go back in time. You have a gun in your hand. You pull the trigger, but your grandfather's unharmed. Why? Because you've jumped into another universe. According to quantum mechanics, every decision we make creates a new universe. Which means, if we break the speed of light, we might not just change the past. We might start drifting into alternate universes. In one universe, you're alive. In another, you were never born. And in another, you might be the ruler of the world. But that's not the scariest part. The real fear is, what if breaking the speed of light shatters causality itself? In normal life, you send a message first, then you get a reply. But if we move faster than light, what if the reply comes first, and the message is sent later? Sounds like madness, right? But physics says, this is absolutely possible. Meaning, an action could happen before its cause. But wait, what about us? If we cross this impossible boundary, what would happen to our bodies? Would we erase our very own existence? Let's assume we somehow break the speed of light, but will we feel normal? Or will the laws of physics rip us apart? Crossing this cosmic boundary isn't just about speed. It could trigger effects beyond our wildest imagination. Black holes are famous for one terrifying effect: spaghettification. Physics doesn't just apply to big objects. It also controls the world at the quantum level. If we move faster than light, even our atoms may start to behave bizarrely. Particles may randomly disappear. Matter could phase in and out of existence. We won't be solid beings anymore, but a quantum blur, drifting through time and space. That means you might exist in two places at once, or you might lose your true form forever. But wait, is there any way to break the speed of light without destroying ourselves? Maybe the answer lies in bending space itself. Most scientists believe breaking the speed of light is impossible, but maybe there's a loophole hidden in the fabric of space-time. Let's explore wormholes, warp drives, and space folding. If we can't beat the speed of light, can we take a shortcut instead? Yes, through wormholes. Think of a wormhole like a secret tunnel, hidden inside the universe itself. Imagine this. You're traveling from one city to another. Instead of taking the long road, you pass through an underground tunnel. Distance shortens, time saved. Just like that, wormholes are shortcuts in space and time. If we don't travel in a straight line, but instead cut through space, we could jump from one galaxy to another in just 1 second. But here's the problem. Wormholes are unstable. The moment you try to enter one, it could collapse instantly. Meaning, if you get stuck inside a wormhole, you might never come back. Until we learn to stabilize wormholes, this idea remains just science fiction. For now, what if instead of moving forward, we bend space itself? NASA is working on a bold concept called the Alcubierre warp drive. So, how does it work, normally? Breaking the speed of light is impossible. But this idea doesn't break the rules, it bends them. Instead of moving faster than light, the space in front of you compresses, and the space behind you expands. What does that mean? You're surfing the wave of space-time itself. Imagine you're standing on a treadmill. You don't move your legs, but the treadmill itself carries you forward. Just like that, the warp drive pushes you through space, without actually moving you at all. According to this theory, we could travel across galaxies, without violating the laws of physics. But here's the catch. To make this work, we need something bizarre, exotic matter, made of negative energy. And currently, we don't have any. So is this just science fiction? Or could we really break the light barrier one day? Movies like Interstellar, Star Trek, and Star Wars make it look so simple. Press a button, warp speed on, and boom, you're on the other side of the galaxy. But in real life, it's not that easy. Physics isn't just a set of rules. It's a prison of reality. Faster than light travel means dealing with time, paradoxes, and quantum breakdown. Even the collapse of reality as we know it. For now, the universe still holds us hostage under the speed of light. But who knows, maybe one day, science will prove everything wrong, and we'll ride space like waves of the future. According to the laws of physics, anything that breaks the speed of light can transform from normal matter into a quantum monster. But how? If we try to break the speed of light, we won't just move faster. We'll break the laws of physics and enter a whole new dimension. And this isn't just a theory, it's a real scientific nightmare. Scientists believe that our universe exists in a specific energy state. This state is called the false vacuum, which means we're living in a temporarily stable zone. But this stability won't last forever. If even a single faster-than-light particle is created somewhere, it could mean game over for the entire universe. How? Imagine our universe as a calm, peaceful lake. Everything is in perfect balance. But what if someone throws a rock into that lake? Ripples. But this isn't water. It's the fabric of space-time itself. If anything breaks the speed of light, it could create a shockwave that pushes the entire universe into a new energy state. In simple words, if we succeed in breaking the speed of light, we won't just go faster, we might send our entire universe back into Big Bang mode. But enough with theories now. Now comes the biggest question. Can this ever become reality, or is it just an impossible dream? For now, physics says no. Light speed is still the ultimate barrier of reality, but the universe has always surprised us. Quantum mechanics, black holes, time dilation, all of these once seemed impossible, and today, they are real. Maybe one day, we'll find the equation that makes faster-than-light travel possible. Maybe, in a distant future, humanity will unlock this secret, reach the stars, and finally break the chains of light speed. Or maybe, we should be careful, because the moment we break light speed might be the very moment we break our reality.